All right, so in this video, we're going to look at how to create a dot plot in base R. And a dot plot basically is like a histogram, but it uses dots instead of solid bars to plot the count of the number of things in each of the categories. Now, for discrete data, dot plots are relatively easy to calculate, but they can be a little bit tricky if we're looking at continuous data, because when we plot it directly, we end up with things not stacking up on top of each other because the values aren't identical to each other. And so we're going to look at some tricks for binning the data in a way that you can actually use it in a dot plot graph. So this is the same inflation data I used in a previous graph, in a previous video. So we're going to reload that. And we have, in this case, we're going to use the strip chart function that's in base R. And when we're going to just plot this directly and see what happens, we're going to specify an offset, which is where the things are going to stack up against each other. Our type of dot that we're going to plot, and we're going to plot them in black. And then I've also added a title and axis labels, and then a tick mark indicator. So if I go ahead and run the strip chart, what we get here is a couple of things that we can notice. So first of all, this tick mark, because it's positive, it's actually plotting inside the graph. In the future, I'm going to make this negative so that it will plot outside the graph, so below 0 instead of inside the data. And you can see that we only have a couple of values that are stacked immediately on top of each other. All of the other values are just kind of stacked up along the bottom because they're all different values. So the way that we're going to deal with this is we're going to bin the data. And I would like to bin the data at half intervals, so 0.5, 2.5, 2, 3, 3.5, 4, 4.5, like that. Now, the rounding operation doesn't really do that at all. And so what I'm going to do is I'm going to multiply everything by 2 and then round to 1 digit, 1 decimal place, and then divide the result by 2 to get my 1/2 intervals. So I'm going to create my inflation rate times 2, and then I am going to round it. You can use the rounding function, or here I use the significant digits divided by 2, and that will get me my 1/2 intervals because I multiplied this. When this rounds to a whole number, when you divide the result by 2, you get those whole numbers go back to being 1/2 intervals. And by multiplying by 2 here and then dividing by 2 here, I haven't really changed the data. I've just rounded it to those 1/2 intervals. And so now if I plot this, and again, I'm going to change this tick mark to negative so that it appears down here and not up here. But basically everything else is the same. I'm stacking as my method. I still have the same offset, and everything else again is identical. And now if I run this, now I get everything stacked up on top of each other because they're the same values. Now, if you use round instead of significant, you're going to get slightly different results, but these are somewhat consistent with our values. Now, the next thing that we want to do is we can change, notice how some of these dots are overlapping with each other. We can change the offset in order for them to line up a little bit better. So I've increased the value of the offset a little bit and left everything else the same. And if I run that, then they're a little bit more spread out and it's a little bit easier to see. I can also change the dot type by using PCH equals some other value instead of 1. There's a whole range of different things that you can choose, and you might want to experiment with them. Online, there's a picture list of what they all end up looking like. But if we run that, then here in this example, now they're square values, and I recolored them as red, so that it looks a little bit more like a histogram, but with, you can count the values very easily. Now, if we build in this hmiss function, then this package, we can add minor ticks to our graph so that we have more than just these little ticks at these individual values. We can add them at specific places. So I've added longer ones and shorter ones in order to have make it easier for me to read the graph with the tick marks. I can also add things like particular values. Now, I'm not going to run this one exactly the way that it is, but you can add vertical lines, for instance, to your graph at particular values. So for instance, let's actually change this to some value that appears on here. So maybe something like 8. If I were to run this, then I will get a vertical line that appears at the value that I posted it. So maybe we could think these are typical values and these are atypical values. That's fine. Whatever you want this line to be, you can add it at a particular location. So maybe you want to plot the mean of the data set or something like that. You can do that. We're also going to try some random data and see how that goes to get our dot plot. So if I run this and I run this, and again, I'm going to round this. In this case, I'm going to round it to 2 digits. And then I'm going to create my strip chart. And again, I'm going to use PCH equals 21 at this case. I'm going to keep the offset that I had in my last example. We'll see how that does. And then again, my tick mark at -0.1. And if I run that, this is my strip chart. So here I didn't have to multiply and then divide. My significance at 2 digits did a pretty good job of lining everybody up nicely. Again, I can also multiply by 2 and then divide by 2 again. And that is another way of getting this data more or less binned. And again, I get a graph that looks kind of like this. This is more or less my normal distribution simulated data. And again, I changed the PCH type. This is a PCH 22. And then I can do one more example. Again, I'm rounding, I'm multiplying and then dividing in order to do my rounding, my binning. And here, again, I've adjusted the offset a little bit and I've changed the PCH type. And so now you do have to be a little bit careful with the different types of plots, the number of quantities that you have. So in my previous example, test 2 dataset had 150 points on it, and you can see that it fit pretty well on this chart. On the other hand, when I increased my test data to 350 values, now it's actually, even though I've reduced my offset a little, it's now running straight off the top of the graph. And so that is something that you might have to deal with when you're dealing with box plots. You might need to create more bins. So for instance, instead of 2 bins per integer, create 3 bins per integer. And if you try doing that, then that'll reduce the number of counts in each of your categories. You'll have a few more bins on the bottom, but they'll be shorter. You can also, of course, adjust the offset. That may make them overwrite each other, or you can try adjusting the PCH type, the point quality character type, in order to also get that to shrink a little bit. So here again, I have more bins, and now they're a little bit, there's more bins and they're a little bit shorter. I could try adjusting my offset again. And again, just, you tweak it a little bit until you get it to display everything on the graph. And I might need to go one more. There we go. And again, you can experiment with this. It can be all the way up to the top of the graph. It just can't be. Yeah, that looks a little better. It's just you don't want it to go over the top of the graph. And that is something that you have to experiment with as you do these dot plots, because especially if you have a lot of data, they will just run right off the graph, and then you have to make those adjustments.